This is Amy. Welcome to my math class. Today we are going to look at sign diagrams. Let's get started. First, let's look at this linear inequality x minus 1 greater than 0. How did we solve it previously? First, we are going to convert the inequality to equal sign, get the solution of this linear equation, which is x equal to 1, and then label this number 1 on the number line. Then the number line has been divided into these two sections. So in the first section, the values are greater than 1. So x minus 1 will be greater than 0. We can use a value on the right to test. For example, we can select the value of 2, let x equals 2, and then 2 minus 1 is greater than 0. Therefore, to the right part of number 1, x minus 1 is positive. Then the left-hand side, it will become negative. Therefore, the solution to this inequality will be x greater than 1. This inequality can also be related to the corresponding linear function y equals x minus 1. We can use x-intercept and y-intercept to determine this straight line. And based on this straight line, we can see when x values are greater than number 1, all the y values are positive. But the values of x less than 1, the y value will be negative. Use the number line to show the similar information. On the right part, all the y values are positive, and then it goes to number 1. After number 1, it becomes negative, so the values are less than 0. But for this one, we only used the number line to show the positive and negative information. So this diagram, we call it a sign diagram, and we are going to use this diagram to help us solve other inequalities. That's question 2. Here we have two factors on the left-hand side of the inequality, x minus 1 and x minus 2. How we are going to use the sign diagram to solve this inequality? Step 1, convert the inequality to the equation. Then we are going to use the null factor theorem. Let the first factor x minus 1 be 0, second factor x minus 2 be 0. Therefore, we obtain the two solutions, x equals 1 or 2. Second step, we label these two solutions on the number line in the accurate order. Then the number line has been divided into 3 sections. For the first section, all these values in this part will make the left-hand side of the inequality be positive. For example, we can select x equals 3, and then 3 minus 1, which is 2, times 3 minus 2, which is 1. The product of them will be positive. Therefore, the first section, the sign is positive. Then the second section will be negative, and the third section will be positive again. And based on the sign diagram, the solution x less than 1 or x greater than 2. So this sign diagram can also be related to the function y equals x minus 1 times x minus 2. Actually, this is a quadratic function, and we know the graph is a parabola. Then we can use sign diagram to show the parabola. To the right part of 2, the values are positive, so all above the x-axis. Then its closest number 2 become negative. At some point, it should turn around and then goes up, pass through the point at x equal to 1. After that, the values are all positive. Then the parabola will be like this. There is one turning point, and this turning point is symmetrically located between these two x-intercepts. It means the turning point is at x equals 1.5. But we only need the sign diagram to solve the inequality. Now let's look at question 3. There are 3 linear factors we are going to use the sign diagram to solve it as well. Step 1, convert the inequality to the equation. And for this equation, we are going to use the null factor theorem. Let each factor be 0 to get the solutions, which are 1, 2, and 3. Second step, we are going to put all these solutions on the number line in the accurate order. So from 1 and 2 and then 3. These 3 values divide the number line into 4 sections. Then first we determine the sign of the first section. Similarly, we can select a point in this section. For example, we select x be 4. Then the inequality, the first brackets are 4 minus 1, and second 4 minus 2, and third one is 4 minus 4. So each one it is positive, therefore the final result will be positive. The first section, the sign is positive. Then we are going to show the positive sign and the negative sign alternatively. Done. And based on the sign diagram, we will need the section 1 and section 3 and show the result using the inequality. It means the result is x greater than 1 less than 2 or x is greater than 3. Done. Of course, for this inequality, we can also connect it to the function. It is the cubic function. Then we are going to use the sign diagram to get the basic graph of this function. So to the right part of 3, the values are all positive, and then it is 0 when x equals 3, and then pass through this point, all the values are negative. And at some point, it turns around and goes to 0 again. After that, the values are positive, but at some point, it turns around and then becomes 0 again at x equals 1. After that, all the values are negative. And we can see for this cubic graph, there are 2 turning points. And for these 2 turning points, it is important to know they are not symmetrically located between the x-intercepts. We will learn how to get the accurate coordinates of the turning point in the near future. For the cubic function, this type, the 2 turning points are not symmetrically located between the x-intercepts. But for the parabola, the turning point is always symmetrically located between these 2 x-intercepts. Question 4. For this, there are 3 factors on the left-hand side of the inequality. But there is a difference compared to the previous questions. There is a term, the coefficient of x is negative. In this case, we are going to put negative sign outside and make this term with x coefficient positive. Then we will have this inequality. After that, both sides divided by -1, we are going to get a new inequality and divided by negative values. The inequality sign should be flipped. We also use the sign diagram to solve it. Step 1, connect it to the corresponding equation. By using the null factor theorem, we will get the solutions. The first one will get -1, second term we will get 1, and the third factor will obtain -2. Then we are going to show these solutions on the number line. Then these 3 solutions divide the number line into 4 sections, 1, 2, 3, and 4. Similarly, we will determine the first section, the sign is positive, and you can use a value to test the sign. For example, we can select x equals 2. Then the first factor, x plus 1, will become 3. Second factor, 2 minus 1 is 1. And third factor becomes 4. And the result is positive. Therefore, the first section, it is positive. And then we are going to use negative, positive alternatively to determine the sign. we would like to get the result with the product be negative, and then we will need section 4 and section 3 show the solution using the inequality x less than -2 or x between -1 and 1. Similarly, we can connect this sign diagram with the corresponding function x plus 1, x minus 1, and x plus 2. Use the sign diagram, we can get the graph. From right is positive, and then becomes 0 at x equals 1. After that, it becomes negative, but it turns around at some point, becomes 0 again at x equals negative. Then it becomes positive. At some point, it turns around and becomes 0 at x equals -2. Then it is always negative. For the graph, it is still a cubic one, and there are 2 turning points. The turning points are not symmetrically located between the x-intercepts. Now let's conclude. Based on previous examples, we used the sign diagram to determine the sign of positive and negative. So the idea is similar to the activity of hand sewing. Now we are going to use this result to solve one more inequality. So this one, there are 4 factors on the left-hand side. And then when we connect it to the equation, get the 4 solutions. Then for this one, we will have the x value be 1, 0, -2, +4. Put all these values on the number line from smallest -2. These 4 values divide the number line into 5 sections. On the right part, we have the values greater than 4. Then it means each factor will be positive, and the product will be positive. The first section is positive, then negative, positive, negative, positive. We would like to get the result of the product to be positive, then we will need section 1, 3, and 5. Then we will have the solution x less than -2 or x between 0 and 1 or x greater than 4. That's all for today's content. Thank you very much for watching. I will see you next time. Bye.